So yeah, it's about caches and backends and about a bit myself and my stupid decisions in my life. So hi everybody, I'm so glad to see you here in this afternoon. I'm so glad you stayed until this one. And we've seen so many brilliant presentations today, and I'm honored to share the stage with all these guys. And let's start with some introduction first. Starting from myself. My name is Ilia, I'm 31 years old, for those who don't know me. And 10 years, almost 1/3 of my life, I used my coding skills to build stuff. And my personal path, it went from web development to backend plus frontend, full stack so-called, and then to backend services, which I'm now mainly focused on. And on my way, I worked with PHP, yeah. Everybody coded PHP when it was 2010, right? JavaScript, and now mostly Python, which you like a lot in AlphaGo, or any other language that makes sense. Also, Redis is another guest on our menu today, and of course, I don't ask, like everybody asks, I assume you all worked with Redis in some way. But for those of you who know it really well, I guess it will not open any new horizons, but maybe you will have a good laugh at my attempts to understand it. So, but for those of you who have never heard it or have no idea, like front-end guys, it's a key value storage, and what it means, yeah, you can write keys with values and then you can read them. And in essence, it's like a hash table. What next? Yeah, we can use it not just a cache, but also as a queue or else. And this else is quite significant because it means you can build many stuff with Redis. And this is also quite fascinating about it because many Redis features, they are built on top of existing functionality. So you take this basic hash table with get, set, and keys, and then you have some other types like sets or hashes, which we'll cover later. And they all use the same key space. So it's cool, but you need to be aware that it works like that and to save yourself from surprises sometimes. And overall, I can call it really minimalistic. What it means, you need to design your own data model most often. And best practice is not like in relational databases like normalization or denormalization. No, it's just what works best. And fortunately, it is flexible. You are not limited to what you can do there. You can optimize your Redis instance to follow exactly your workload, specifically for your project and circumstances. Now I will tell you a story about one small but very busy process. And yeah, it's a real story, by the way. It happened to me as a client. I will not use any client-related stuff, but you will understand. I hope so. So what do I mean by busy? Well, I don't mean it takes all CPU time it can. I also don't mean it spends like most time in I/O things. I also don't mean that we want to read results all the time continuously, and I also don't mean that we want to write them continuously to refresh them all the time. I mean, we need to do all of it. We need to do it all the time. So, what do I exactly mean? Yeah, this is my NDA safe version of a project I worked with. Also very simplified, also very pruned to just keep the essence of it. And say hello to it. It's called HEM, Hungry Estimation Model. Why hungry? You will see. It's about events, right? Events. Events, they happen every day, and they are scheduled. And they can be scheduled like for a day, for 2 days, for a week, or even a year ahead. It is also about changing events. They can be changed with actions. Business can decide, we want to change the venue, we want to change the date, we want to change the maximum capacity. and it will mean something to in the end, it will have consequences. And what consequences? They depend on time. If you decide to move your venue like a week in advance, it's one thing. If you move it like one day before, then it's a different thing. Different time, different consequences. And what do we have in total? We have this model, estimation model. So it depends on time, it depends on event, it depends on action, and it produces report. And report is our product. Report is what we provide to our clients, and yeah, it has valuable information. And what are the requirements to actually provide these reports? So what else do we need to consider? First of all, good thing. Good news is that we don't need all the reports, just discard them, forget them. This is so good because I don't need to store them and archive them. Yeah, something's going on with the screen, I can tell. It's like your video card's been doing too much CUDA stuff recently. All right. But second requirement is not that nice. Time, this precious time, it has to be always within 1 hour from now. Meaning that at least 1 hour, at least once per hour, we need to recalculate the whole thing, the whole scope of events and actions we want to estimate. And the last one, it's just an okay thing. Reports have to be available to clients by day or event. It is okay, but think about it. How many events and different actions can happen to these events per day? A lot. I could say like it's tens of thousands. And these tens of thousands reports, they need to be available at once. So something to keep in mind. So what do we do? As we use Python, it's slow and bad for you, but we know how to make it work for us by utilizing as much CPU as we can. So in this first attempt to make it work faster, we implemented multiple workers and API. And yeah, workers get executed on schedule. They produce reports to Postgres. And the API just uses these reports to send them back to clients. Of course, we based our estimation process on data lake. So this is where I/O constraint comes from. But we solve it by replicating this whole thing of data lake snapshot data inside our Postgres. So what it means is that we solve I/O by this. We solve CPU by actually not solving it. We just parallelize. But we still have read and write concurrency, which we need to fulfill. And then when surprises start to happen. So what is the issue with this design? Okay, we don't have time for you to think. It's just a bottleneck here. Postgres, what we need to do with it? Yes, we just move it away. We move it away into Redis. So just notice here, I forgot to mention these bold arrows. They stand for the read path for clients. So bold arrows is where our data, it comes to clients. And yeah, I also forgot to mention, our clients, they need to receive the JSON less than 1 minute per request. That is not so small amount of time, but it's our limit. And thin arrows, yeah, it's just estimation related data transfer. So we can parallelize it, we can optimize it. But with bold arrows, we cannot do much. Clients come, they send requests, we need to do something. And if we keep just forwarding everything to Postgres, sooner or later it will crash. And we found it while testing, so we moved all the reports to Redis. And it looks like it's gonna work for us because we don't have like a huge data. It's quite moderate size. So let's just follow best practices from documentation. Let's just make it simple and minimal. It's just cache. Our data, yeah, is moderate, so the basic stuff would save us. So the first design comes. Yeah, Yeah, it's okay. So the first design is very flat. We just save our reports per key. Yeah, we can find a key per report and we can save them. And at first it looks like this. For each report key, we find this, we build this expression based on day, event, action, and UID. So doesn't mean much, but for me, it looks like I can find all events from a day, right? And then I can send them. So I just search in Redis with the prefix of day, and I can find all events for a day. That's what I needed. But then it started to like this. And then, yeah, next idea, I learned that pickling in Python is faster than JSON serialization. So what it means, pickling, it's binary serialization that exists in Python. You can just take every object and serialize it to a file, or just to a byte chunk, and then deserialize it. Nice. And it's faster than JSON for our case. So yeah, let's just use it. And now we store pickled bytes in Redis, and it works faster by 10%. Awesome. But how do we actually read from this cache? And this is where we use scan. Okay, nobody used Redis, I see. Because, yeah, scan is going to be our main guest here. Redis is just a topic. So what's about scan? Scan works like this. First of all, we create a cursor, and cursor is lightweight. It lives nowhere, basically. We create it by sending 0 here, and then match expression, so which looks like this key, right? And then we just start to stream our keys batch by batch, and the way it works is that on each network round trip, you receive some batch of keys. And you need to send this scan cursor, which is just an integer. Every time you receive it, you send it until it becomes 0 again or something. Yeah. And I have to say, this is an advanced way of finding no keys in your database, matching a pattern. If you Google it, it will be this. It is also a recommended way to use, on contrary with keys command, which blocks the entire database. Scan doesn't. Yeah, it doesn't work as fast as I expected. So remember the second, oh yeah, can I actually point, right? Yeah, remember this second design. So now we can run multiple scans at the same time for multiple actions, and supposedly it should work faster, right? And it worked faster, like 5% faster. Wow. And yeah, what next? Okay. What next? This pinnacle of engineering creativity allows for byte-efficient encoding of data using this intuitive data format. Yes, it is basically a data format here. So real eye candy, right? Luckily, it didn't kick off. By the time it became clear that scan, this scan that is default way to find keys in Redis, it is not what it seems. And to put it short, it's just weird. I think it's weird, and I still think so. Although I learned how it works, and I'm going to share. I still think it's weird. And if you find like working applications for scan, please tell me. Yeah. Are we on time? Chairs are still here. Nice. So, but yeah, let's be honest and fair. I mean, Redis is cool, scan is cool. People spend some time, open source. We respect that. So, what's like pros and cons? So this is slide number 10. Yeah. What does documentation say about scan? This is actually pros and cons. They are just stripped from documentation. And yeah, a bit of my experience. First pro, good point, it can run in parallel. Yeah, this is the point. You can just run as many scans as you want from the same session, from different sessions, doesn't matter. And it works. It's not an issue for a server or anything. Next one is, cursors in scan, they are disposable. It's actually just an integer. Maybe it has like a separate hash table inside Redis, but it's nothing else. There's no like a session with some history behind it. So if you drop a connection, if our clients drop connection, they just want is too big, they just, okay, forget it. Next time you will get it. And our cache is still working. So it's good. And also it's non-blocking, meaning that, the database is still possible to change, to read from while you do your scanning with these batches and everything. But there is a hint issue with it, and we will cover it later a bit. And what's wrong about scan is the first thing I noticed, of course, and I have seen it in documentation, that it returns duplicates. And it's like a minor issue. You can live with that, I guess, but it's quite confusing. Imagine you have to like read a lot of keys and then do some fetching on top of them. And it means that you need to store all these keys you have fetched because you don't want to have duplicates in your response. So it's kind of not cool. Could be better, right? And second, sometimes it's just empty list. And it's like even less a major issue, but for me it was confusing very much. Like, isn't it a weird thing when you receive an empty list and then you just need to forget it and wait for another one? Maybe it's also empty. Yeah, I felt like we are doing something wrong with this scan stuff. It all came into my understanding that the issue with scan is it is always ON. It's always ON, and by N I mean it's number of records in the whole database, in the whole key space, with all things you have there. And why is it like this? Well, like you said earlier, it doesn't matter for scan which prefix you use. Is it like specific? Is it just a wildcard without anything, or is it just empty? It does matter for you though, because you have to read more keys, and you have to fetch more values. But for Redis, it doesn't matter. It will go through every record. Why? Well, because it's a hash table. In hash table keys, they are not, you cannot say anything about them. It's just numbers, and you only can go through them. And also another issue with it is as the database grows, and our database was growing really fast, although it's not a big one, but as we keep adding new data and deleting old one, it just grows, because this is how Redis works. First it's like 64 something, then it multiplies by 2 and by 2. And if you want to know more about this, I really advise you this article. It was my eyes opener. I have no idea why, because there are also other articles which are quite good, but only this one actually made a click in my head. And it's like a marketing stuff for KDB, but believe me, it's good. The content is good. Sometimes marketing guys can write good stuff. All right. So, no more scanning. We cannot do it. It's too expensive. I mean, it's not expensive, but it's too slow. It's just too slow. So what do we do? Well, the first thing that comes to my mind, make your own cache. And of course, I do it like this. Just use the same design, remember basic stuff, but also, in addition to storing reports, I also going to store my keys. And I'm going to store them by day and by event. And you know, guys, it worked good. It worked well. And the performance gain was it was like 100 times more faster. I mean, I was so stupid for using scan. I don't know why. But with this approach, it worked, blazingly fast. But there is an issue with this design. And first of all, how about retention? So let's say we have some time to live configured for keys, and then we get them from set, and then we cannot find half of them. Okay, maybe we can live with that, but our clients, it will look like this for them. You fetch like reports from yesterday, and as the day grows and goes to the end, you receive less and less reports. It doesn't make sense to them, right? So another issue is that you also have to yeah, you have to manage your key space. You now have this keys prefix, and it's like fixed, but you also have report key, which can be anything, right? Yeah, of course, it won't be ever keys, but yeah, if you do immigration or anything, you need to keep it in mind. And it's, yeah, not nice. So, it was like, okay. Yeah.
You mentioned that you build your own cache.
Yeah, it's like a cache, like indexing on top of
That is like
cache, yeah.
on top of Redis, or it's like they put another stack?
No, it's just like design for a cache. I mean, of course, it's not my own cache. I didn't build a hash table myself. It's just the design. That
On top of Redis.
because, yeah, what I mean is if you compare it with the relational database, there you create a table, right? Then you put some indexes and it's done. But here it's not like that. These are basically our indexes, as in Postgres we would have.
Okay, so it's just an
Yeah,
abstract design.
yeah.
It's not like you use like
Yep. There is no abstraction that you can use in Redis like index. You need to build the index. You need to also maintain it. Yeah. Or maybe there is, but you can correct me, of course. Yeah, but we wanted to move to something more future-proof, and with the help of our technical lead, we came to this design. So here we use hashes. Hash is a special data type in Redis. It's like a key value inside a key value. You can think of it of a document, like, but with only one layer. And we had 2 hashes for day, for event, and it's clean, it's clear. Everybody understands how to work with it. Yeah. When you want to like receive reports for specific action, you have to download the null, and then you filter them in Python. Oh my God! But you know what? It works faster than scan, so I'm fine with it. So, with all things considered, this design was approved and implemented in the next release, really with no issue because it's Python, right? Demonstrating that read performance was quite decent, and tolerance to bursts of client requests was also quite good. No issues since then, and now it is approved and still working, by the way. So, oh no, this is not true. Yep, I still have some slides. So, as it's a technical talk, I needed to provide some numbers to you guys, but I'm too lazy to make sense out of them. So I just remembered like 3 numbers I could remember. And the first one, it doesn't make any sense with Redis, but it can give you an idea about the service. 50 gigabytes of bloat has been cleaned up from Postgres by manual vacuum just like last month. So what is vacuum in Postgres? It's like space which is now not used because it was cleaned up, but it wasn't really cleaned up. So data is deleted, but it's still taking the bytes. And auto vacuum in Postgres is not perfect. And if you don't know how to configure it, and you do a lot of deletions, my advice just do the vacuum manually in some scheduled task or something. Because this thing is not just stays there, it also concerns you because your queries, they run slower. Next, this is a shame slide. 7 CPUs are used all the time by the estimation service to actually do the estimations. Python is very bad for our global warming, and we're going to solve that soon by doing like intelligent scheduling maybe and optimizing even more. But for now, it's like this. And all these processed reports, they keep read to Redis and written by clients. And this is my invention for this. The only thing I really invented, not cache, but this metric, measure of API throughput. How many megabytes of JSON can your API throughput per second? If you can share your results, let's compare our API throughputs like this. It's fun. It's fun. Yeah. To summarize, I wanted also to say like a couple of things. I hope it was easy for you guys to follow this talk. I tried to make it easy and approachable. This presentation is not a success story, and I'm not trying to teach you much. It's a story of trial and error, and it's common, but not so remarkable. But still, I think that it's wise to learn from common experiences. They happen more often, and they can happen to you as well. Knowing common pitfalls of tools like Redis is not less important than knowing how to squeeze all the juice out of it, which is also cool, but maybe in next release. So first lesson is know your tools, and yeah, find how to do your thing. It's only the first step, but try answering what exactly are you doing, and why does it work? Yeah. Just answering these questions might really change the way you look at things. And the second lesson, of course, is discover alternatives. Discover, I mean that, yeah, discover them. Make it something you like, because learning new technology or learning new features of good old better tested products is always beneficial in the long run. By understanding software design, new software design for you, we also adapt the way of thinking that people who implemented the software had. So we kind of share the same mindset, and it's good, because you wouldn't argue that people who built Redis are smart. So you want to have the same mindset, right? So without realizing it, we start to think differently. And we start to apply our new patterns and find new answers to old boring questions. So it's good. And of course, experiment. Theory is dead without practice. I could think of many ways to optimize bytes in my Redis cache, but if I want tested different approach, I would never know that it works so much better. So make it happen, see it working, measure it, and compare with other ideas. The reality is that ideas, they don't have any value, actually, guys. Idea is only a door. It's like a portal to new experience. Just looking at the door doesn't help you to open it. Well, unless you are cat. Yeah. Thank you for listening and staying until the end.